Good morning, year 12, Luca and Joel. First of all, my apologies for not having yet got any extra work for you for Mrs. Ferran's bit of the course that she's doing at the moment. I've been trying to put it together, but it's difficult because I've got to try and explain the next step, and it's quite hard to do not face to face. What we're moving on to, what you've done so far is preparatory work, really. Look and see, and I believe you did some differentiation techniques, which incidentally you're going to need for what I'm going to give you to do today as well. But from that, we have to sort of make a leap into the world of differential equations, which I'm sure you're both familiar with them, but it's getting it right. So I'm still sort of working on that, and I will get back to you very soon with the next step in that little bit of the journey. But I've got to confess, I'm finding it difficult to do it remotely. I'd much rather be face to face with you and explaining it that way. Anyway, that's coming soon. For today, I've just got one thing for you to do, and it's the topic assessment for Maclaurin series. I don't think there's any real benefit in you now working through the 3 exercises that Integral Maths provides as far for Maclaurin series, having done the other 2 exercises that I've set so far from the AQA textbook. They cover all the things that you really need to know in order to be able to do this assessment. But there's still things in here that I need to explain. So I'm just going to go through the assessment now and explaining what you're supposed to be doing for each question. So I would definitely advise you to listen to what I'm going to say about this before taking this on. Maybe just keep coming back to the video as you start each question to check you understand what it is you're supposed to be doing. So here we go. Right. Oh, one more thing. It would be helpful to have your formula book available while you're doing this, because you will almost certainly need this page here with the expansions, the standard expansions. That's these ones here. It's also got a copy of the formula here. You can ignore these. These are Taylor series expansions, which is a kind of generalization of Maclaurin's that we don't need to worry about in our course. The main thing to look at are these things down here, and obviously the formula, which I'm sure you're probably familiar with now anyway. But have that available. And also, I'll explain why this page here might be useful to you as well, which are the standard differentials that you're allowed to just quote in an exam. I'll come back to that in a minute. Right, okay, so here we go. So, question 1 gives you a function, quite a complicated looking function, and asks you to differentiate it, and then differentiate it again, and then differentiate it again. Why are we doing this? Because we're trying to form Maclaurin series for that very complicated function. The only difficulty with this question is in knowing how to differentiate a product. Now, my understanding is that you have done this with MIS. It's called the product rule. You might have come across a formula along the lines of v du dx plus u dv dx. Basically, it's quite simple. You differentiate one part of the product and keep the other bit the same, and then you add to that the differential of the other bit, keeping that one the same. So as long as you know how to do that, you should be able to differentiate that. If not, let me know ASAP, and I will give you a little bit of a explanation of that so that you can actually do that question. Because without knowing those facts, you definitely wouldn't be able to do the first question. But assuming that you can do that, you should be able to differentiate that, and then differentiate the result of that, which will be even more complicated, and the result of that, which could be even more complicated. Stick in your noughts to find the first 3 series. Straight away, quite a lot of work involved in that first question. But interestingly, it's actually, I think, pretty much the only question where you have to do Maclaurin's from first principles in the whole of this exercise. The rest of it, you're going to be using the standard results that I flashed up on the thing earlier. So let's just have a look why. So question 2, it says use known Maclaurin series. You are allowed to use those results that I just quoted to find the first 3 non-zero terms for the following functions. So what have we got here then? Right, well, the first one, sine x squared, can be done by substituting x squared in for x in the standard Maclaurin series expansion of sine x. I'm not going to explain that. You hopefully understood what I meant then. The second one, you got a little bit more interesting. This one is, oh, this one's a fun one. It's cos squared x, which basically means cos x times cos x. So you're going to have to times together the two series expansions of cos x as two brackets. You'll be familiar with this technique if you read through the examples and tried the questions that I set you last lesson from the other booklet. So you basically write out the expansion of cos x twice as two separate brackets and times them together. But obviously you don't write all the terms out because you haven't got an infinite amount of time. So you just write out the first few. I don't know, maybe the first three, I should think, maybe even only the first two. Not sure, you'll have to do it and see. But that's what you need to do for that one. And then for the last one, this is another fun one. The ln of 1 plus sine x is done by using the standard expansion of ln of 1 plus x, which is this. And then, you're going to love this. For each of the x terms, you replace it with sine x, like that. And then you have to expand each of those sine x terms using this expansion to get in a horrible, complicated little algebra mess. And then you've got to sort of simplify that to get it to just be three non-zero terms. Rather you than me. But I'll leave it for you to take on. And again, if you haven't got a clue what I'm talking about, just get back to me and I will help you. Right, question 3. They ask you to differentiate sine to the minus 1 and 3x for 2 marks. Now, if that was worth more than 2 marks, I'd be assuming that they want you to do it from first principles. Or what I don't mean from first principles, I mean do it implicitly. But I haven't technically covered that yet in maths. So I think what they're actually asking you to do, as it's only worth 2 marks, and this is where that other page comes in, which I'll bring in back to you, is to just use the standard result which is here, which is quoted to you, and then do a kind of a chain rule thing, which I hope, again, you've done with Miss, where the x is replaced with 3x. So chain rule, just go over it again. It's where you have an outer function, which is the sine to the minus 1, and an inner function, which is the 3x. And the way to do that is to differentiate the outer function, sine to the minus 1, which gives you that. But don't write x, write 3x here. And then multiply all of that by the differential of the inner function, which in this case is going to be 3, because it was the differential of 3x. Whew, complicated stuff. Then, for reasons which aren't immediately clear, they ask you to find the first 3 terms in the series expansion of this thing here. Now, this is just a standard result which you will do in normal maths soon, and it's the binomial expansion, which I haven't actually given to you. Oh, that's a bit of an oversight. I haven't given it to you. It's in the formula book, but it's not on this page here. It must be on a different page. So you're looking at the binomial expansion, and the binomial expansion will give you the expansion of 1 plus x to the power of n, where n is a rational number. In other words, it doesn't have to be a whole number. I won't spoil the excitement by telling you what it is, but you can actually see what the value of n is for this. And you can also see what the value of x is for this, because it's not x, it doesn't say plus x, it says minus 9x squared. So the x is actually minus 9x squared. And that's what you must sub in when you're subbing into that thing which you'll find in the formula book. I'm not going to explain why, but the result for this and this are kind of related and will help you to do this part of the question. You'll have to think about it, but knowing these will allow you to do this if you understand what the hell's going on with all this work. Finally, on to question 4. Again, you don't need to do these from first principles. You can just use the standard result here, ln 1 plus x in the expansion here. So in the first one, you're replacing the x with 4x. In the second one, you're replacing the x with minus 3x. And to do this one here, well, I'm not going to tell you how to do it. But something you did last year, or this year if you like, should allow you to do that one. I haven't talked much about validity. Some of the series expansions are valid for all values of x, most notably e to the x, sin x and cos x. But ones of an ln are only valid for a set of values, and this is the set of values it's valid for. Now, if the x isn't an x but is something else, you can still use this validity, but you must then change that to, say it was 3x, you put a 3x there, and then divide by 3, and that would become minus a third, and that would become a third, as an example. So using those ideas, you should be able to find the validity of this statement here, assuming you knew how to do part 3, which I'm not going to go over now. I feel like I'm talking in riddles. And then the last one's a substitution one, where you put a value in to find an approximate value for something. It's a lovely exercise to get your teeth into. You're more than welcome to ask me questions about it when you get stuck, which, to be honest, you probably will at some point. But have a go at it. We'll set a deadline of a week. Okay, so do it in a week and submit it to me when you've done it all. But that should be a little bit of fun for you to take on. And it's all I'm going to set you to do today. However, there's one more thing I want you to look at, and that is to start to discover the new exciting maths website, Rosemont Maths website, which is full of past papers relevant to maths and further maths. I've been putting the further maths papers on there myself. I've actually done some of the work on this. Mainly it's Mr. Richards doing it all. But that will be our vehicle for delivering past papers next year, and we're hoping to keep expanding it, not just with more past papers, but with our solutions. Even video solutions may start to appear on there, which with our new video recording skills that we all now have. Very exciting times. But please have a little look at it. I've put the link on the classroom here, and see what you think about that, because I'm quite excited by it, and I hope you'll find it exciting as well. I'm going to be talking soon about the legacy papers and how we can use those for extra questions to help us get ready for this Unit 4 exam in the summer, next summer. Right, that's it for me for now. Please feel free to message me. I'm around here all day, so I will pick up your message and get back to you as soon as I can. Thank you for listening, both of you. Hope you're both well, and I'll speak to you again soon. Bye.